I'm responsible for Hyprogeo, which is a project funded by the European Commission. The vision is to give EU competitive and greener independent access to space. Our technical objective is to show that Hyprogeo can become a credible, competitive technology for space system missions.
We have to develop 4 key elements. The goal is to achieve air efficiency over long burning durations, typically half an hour to an hour burning, that is beyond currently hybrid propulsions that has been developed for launcher applications. We have also to develop an high endurance nozzles to be able to withstand such long durations and to cope with high stresses and thermal loads. The third goal is to develop a European source-based high concentrated HTP productions, and also developed an RCT based on monopropellant HTP.
We anticipate that the major impact of the work we're doing as a team in Hyprogeo will be to position satellites in this geostationary orbit so that the satellite rotates around the Earth once every 24 hours. The main achievement so far is the production of this characterization bed. And here we are at IOA, the Institute of Aviation in Warsaw, and we're about to do the very first tests using 98% concentration peroxides. So the unknown is whether it'll survive at a higher temperature that we require for the Hyprogeo hybrid rocket.
Here we have the fuel tank, so as we just saw, the fuel grain is located in this part. Here we have the decomposition chambers in which we have the catalyzer, and this part is called the injector ring. So the oxidizer is injected in this piece close to the fuel grain surface. And after this part we have what we call the combustion chamber, the part in which the gaseous oxidizer and the gaseous fuel react. So here you have the nozzle exit section from which the gaseous are ejected from the engine.
The catalytic injector, its main job is to generate hot oxygen, and the hot oxygen is introduced into the combustion chamber for the Hyprogeo hybrid rocket. When that happens, there is a very rapid chemical reaction which releases the combustion gases. Those combustion gases that produce the thrust for the rocket. So my role is to perfect the technique of catalytically decomposing the hydrogen peroxide very, very rapidly using a catalyst which we call PX1.
The second line is dedicated for heating the catalyst bed, and of course, as similarly with main line, we have a small tank with capacity to 0.75 liter. Before refilling, we make a vacuum valve that is connected with a vacuum pump. We open the filling valve and the vacuum valve, so we have circulation, and we suck by this flexible tube the lower concentrated hydrogen peroxide.
So what's the difference between a plane and a rocket? Well, both use a fuel and both use oxygen to burn the fuel. The plane takes the oxygen from the air. The rocket cannot do that, it takes it from a tank. That gives the rocket the ability to fly into space. Now what's the difference between a hybrid propulsion system and a normal rocket? Well, a hybrid propulsion system uses a special type of oxidizer. In this case, the Hyprogeo project, we use hydrogen peroxide. So we meet all of these experts within here in Evonik.
My name is Philip Christ. I'm a chemist working for Evonik, and I'm taking care of production of hydrogen peroxide at a high concentration, say 98% or higher. This is our crystallizer that we use to produce the peroxide starting from 87.5% to 98%. So actually when hydrogen peroxide decomposes, it only produces water and oxygen. There are no toxic chemicals that might occur when using hydrogen peroxide. The key achievements in the end are that we get to a safe, reliable process and that we find materials that we can use to build our full-scale plant.
Nammo is responsible in the Hyprogeo from design to manufacturing of the nozzle. The size that we are talking about for the Hyprogeo nozzle is about the same, but bigger than this, especially in the front part. It has an inlet part that widens up and is a conical part that goes directly in contact and in connection with the combustion chamber developed by Unera. While on the back it's somewhat the same because the nozzle that we are going to test is the one for ambient testing. So we plug it and play the engine in ambient, and then the shape of the nozzle is precisely designed for working at best in these kind of conditions.
Hyprogeo is a really interesting project because it's really the first time we've used very high concentration peroxide, in this case 98% peroxide, which tends to decompose and generate a higher gas temperature. So in this thruster we were really pleased with the gas temperature we were seeing at over 900 degrees C gas temperature. In terms of ISP, which is like our miles per gallon, if you like, for rocket engines, we were targeting a number of 170 seconds and we far exceeded that with 183 seconds ISP. So we were really pleased with that.
So there's a big transition between chemical and electrical propulsion in satellites. The electric propulsion provides a significant increase in lifetime, but it has the main drawback is that it needs several months for the satellite to reach the orbit. And Hyprogeo is there to bring the satellite in orbit within some days. The biggest challenge is to get it commercially attractive for the customer. If this is given, we could implement it within 3 or 4 years. All the spacecraft or space companies within Europe are joint companies. We need the strength of Europe to build such a project.
What looks like a misguided cooking experiment, some sort of a tarte flambée, is in reality nothing else but rocket fuel. This is high-density polymer ethylene, the rocket fuel of a hybrid engine, of the Hyprogeo rocket engine, which is being tested here at Unera, the French aerospace lab here in Toulouse. And this is the test stand, which will be busting with activity in a few minutes when all the engineers and scientists will come to fire this engine to see how well it is really performing at last. Engine in the background, all set up for the next test, but before this is happening, we have a few questions. And we discussed these questions with Anthony Lecossé. He is the Hyprogeo technical coordinator. Anthony, thanks for taking the time. What was your first thought when somebody told you you become the technical coordinator of this project?
It was quite a challenge because Hyprogeo is a very huge project. You know, we have more than 16 partners. I am, as the technical coordinator, in charge of ensuring that everybody is working on the same mission, with the same objective, and ensuring that at the end of the project we'll have fulfilled our objective. And the main objective in this project is clearly the hybrid thruster demonstrator, and I'm proud to say that it's developed and working very well.
The ambition is to study a propulsion module based on hybrid chemical propulsion. Its application could be very attractive if we apply it to transfer module or to kick stage module to allow a more efficient way of bringing the spacecraft to their commercial orbits.